In this episode, the fastest passenger train on the planet.
It's flying pretty much at 431 kilometers an hour.
Seemingly defying the very laws of nature.
The train floats at 1 centimeter from the guideway.
And the pioneering historic innovations.
Wow, it looks like something out of the future.
I don't think without the L we would have had this great, vibrant American city that we have today.
That made the impossible possible. To take the Transrapid system to record-breaking speeds, engineers could draw inspiration from a trailblazer of the past.
They combined the principle of the hovercraft and a jet engine, and they smashed the rail speed record.
To create their own impossible engineering. In the French countryside, physicist Andrew Steele is looking for the remains of a system that could have been every bit as revolutionary as the Maglev.
So, here it is, over 50 years old and covered in moss. This is what its creators thought would be the future of high-speed mass transit. A single concrete rail straddled by a train capable of travelling at 422 kilometres an hour, at a time when the speed record for a conventional train was just half that.
So what kind of vehicle was capable of overcoming the forces of friction to travel so fast? The answer lies in a closely guarded warehouse.
I've come to a top-secret location somewhere outside Paris to get a rare look at what could have been the future of land transportation.
Hello.
Good morning. So, where's it kept?
Hidden amongst an assortment of military vehicles collected by Thierry Farge are the last surviving examples of an extraordinary experiment.
Wow. So this is the Aerotrain?
Yes.
It looks like something out of the future.
Designed by engineer Jean Bertin in the 1960s, the Aerotrain 1 and 2 are the only surviving prototypes for a system it was hoped would change travel forever.
You can see the Aérotrain doesn't have any wheels. Now, that might seem strange, but although wheels have been the basis for land transport for thousands of years, they come with a big disadvantage, because the wheels rub against the ground, they create friction, and the Aérotrain tries to get round that. Engineers and scientists have been toying with the idea of frictionless travel for some time. The idea is that if you can remove that frictional resistance to motion, then you can make things travel faster and more efficiently. The simplest way to do that might be to levitate it on a cushion of air, and that's the principle behind how a hovercraft works. We've got our own very simple model of a hovercraft here. It's just a CD with the top of a drinks bottle on it, and then a balloon. Before we inject that cushion of air, the CD only moves a very small distance across the table when I tap it. However, what we can do is attach a balloon to this drinks bottle top and see if that makes any difference to the way that the CD moves. So, here we go. You can see that now, with a tiny tap, the CD moves a long way. And just as long as the balloon's got some pressure to force that air down underneath the CD, then it'll keep on moving around freely. But when the balloon runs out, of course, the cushion of air vanishes and the CD is just as hard to move across the table as it was before. In here, we've got the guts of the Aérotrain. And incredibly, there are just two regular car engines which power massive fans, and that blasts air downwards to lift the train up off the ground, and then inwards to keep it centred on the track. That means that the train isn't in contact with the ground or the track, and so that source of friction is removed, and that means that more of the energy from this engine up here The propeller can be used to power the train to move forwards. It's 11 metres long, weighs 2.6 tonnes, and yet the air gushing out of these nozzles was enough to keep it floating 2 or 3 millimetres above the track.
By 1967, the Aerotrain was already proving its potential on the test track as a new form of speedy passenger transport.
It planned to build a track for the Aerotrain between Paris and Orleans, 65 miles in 35 minutes. Vive la sport!
But for Aerotrain Mark II, Bertin went all out for speed. The Aerotrain 2 was a futuristic hybrid of jet fighter, racing car, train, and hovercraft. And although it looked like something out of a sci-fi movie, the technology itself was fairly basic.
I think my favourite control is this one that goes marche and arrête, so it's basically stop and go just by flicking a switch.
Nevertheless, it was the combination of engineering ideas that made Jean Bertin's Aerotrain groundbreaking.
Bertin's ideas really were revolutionary. They combined the principle of the hovercraft and a jet engine, and this was the first time it had ever been done. Combined, they smashed the rail speed record.
An aircraft jet engine gives initial thrust up to speeds of around 185 miles per hour. An additional rocket motor boosts the MPH to 235.
Sadly, Jean Bertin's dream of friction-free travel died in the 1970s when the French government abandoned the experiments. However, the Aerotrain now has a familiar-looking cousin, over 6,000 kilometers away in China.